Today's lesson is to review and extend your concept of adding fractions. These fractions are going to turn into rational expressions, so we need to make sure that we can extend what we know about adding fractions into algebraic fractions, and I'll refer to those as rational expressions. The key idea is you have to remember you must have a common denominator or common denominators to add or subtract any expression with fractions. So your concept that we're reviewing is whenever you add or subtract fractions, you have to have a common denominator. If you do not have a common denominator, you'll have to create an equivalent fraction. So that's what I'm highlighting here in that olive color. To create an equivalent fraction, you must multiply the top, called the numerator, and the bottom, just to review, the denominator, by the same value. So I have a couple of examples here. If I have 2/3, one way I can create an equivalent fraction is to multiply on both top and bottom by 5, and it creates an equivalent fraction as 10/15. What we're going to be looking at is more like example 2, where we're going to have a fraction like 2/3, but we're going to want to create a rational expression that has an algebraic expression in it. So as long as I multiply the top and the bottom, x plus 1 and x plus 1 on the top and the bottom, we can create an equivalent expression. Now the final expression I have here is using the distributive property, so that's 2x plus 2 all over 3x plus 3. So creating equivalent fractions is a skill that we'll have to have mastered as well, and just reviewing those concepts quickly. I try to outline a few steps in adding and subtracting algebraic fractions. So step number 1, always put the denominator in factored form. If the denominator is already in factored form, you can leave it. If it's not, you're going to have to factor. So in anything that you do with fractions, what you need to remember is always factor first. I'm putting that in red because the very first step is getting it in factored form. We really are going to focus on the denominator for addition and subtraction of fractions. Step number 2, after you have it completely factored, compare the denominators of your expression and determine, are they the same? If they are the same, then you can go right on to the next step 4. If they're not the same, you're going to have to determine what a common denominator is. So that's really what we're going to be doing. Most of our denominators will not be the same. We are going to determine the common denominator, and I'll describe that through some examples. In step 3, once you figure out what the common denominator is going to be, you're going to have to create equivalent fractions like I demonstrated in example 1 and example 2. To create those equivalent fractions, multiply the top and the bottom by the same value. Now this value will be determined by whatever you need to use to get your common denominator. So this is really more or less going to be determined by what you did in step 2. You identify your common denominator, and then you're going to have to create equivalent fractions. Finally, once you have those equivalent fractions created, then you multiply, and most of the time we're going to need to distribute, because we'll have algebraic expressions as needed, and then collect our like terms. If you remember from our fraction works, whatever you do, you're going to leave the denominator alone. Once you get your common denominator, then you're pretty much done with that part of it. So that's a quick review of the rules and the concepts that we're going to review. I'm going to put this in a separate video, and then I'm going to come back and show you some exact examples of them.